Welcome to the tutorial about using Electroprint. First thing first, you need to import a step or STL file, your original 3D object. Just click on Import 3D, select your 3D file. Now you must consider the orientation of the part. Exactly like in a slicer software, click on Orient Part. This way you can select the face you want to put on the build plate. Now you can import a Kicad netlist by clicking the Import Netlist button. For now, only Kicad netlists are supported. You can select the Kicad's footprint folder by clicking on Select Footprint Folder. By clicking on Generate Components, the software will make links between the content of the netlist and the available footprints. If a footprint is not available, the software will alert you and still generate a generic component. You can see that now the components appeared on the build plate. If a component could not be associated with a footprint, it will appear with a red block. Let's look closer. The green rectangular block will create a cavity to receive the component. The component's pads are vertically extruded, but there is a part who goes inside of the block. It's called undercut. It's very useful during the assembly of the component. When you push the component while heating the pads, you need some space for the component to properly sit on the pads before reaching the bottom of the cavity. It's included to allow a better connection between the component's pads and the 3D printed conductive pads. Let's click on Move Component. It will allow you to click on a component and drag it with a constant vertical position. When a component is selected, you will see on the right panel that you can modify a lot of parameters like block size, the pad size, orientation. The active cavity check allows to keep only the pads of the components to, for an example, use them as external connectors. You will just have to click on Apply to validate the change. Let's take a look at the burial analysis. It's a Boolean operation to verify that your components are not too close to the object's border. This, in this case, could result in the component cavity being open to the outside. Now, let's click on Routing mode. You can create a route by clicking on a pad. You will see a line who indicate which pad is the closest one on the same signal. Just click on the next pad to end the routing. If you need, you can route vertically. During a routing, just push the B key. Your preview will appear vertical. And when you click, the preview will go back horizontal. Since routing vertically can be quite difficult to find the right altitude to click, you can push the N key during a vertical routing to reach instantly the right altitude for the next pad. The track editing mode allows you to displace your track or your track's nodes. The Resistance Probe button allows you to click on two pads from the same net and estimate the track's resistance between them. The default value is the one I obtained from my test with carbon nanotubes infused PLA. When you are finished, you can go to File, then Export Step. Open the step file in your favorite slicer with a multi-material capability. Once opened, you just need to know that the first element is the main shape. You can select the next elements and affect them to the conductive material. Be sure not to use the function to add support everywhere. Do a first slicing. You will see that the cavities are ready to receive a component, and the tracks appear properly. You just need to add the poses at the right layers. So you will be able to insert the components during the prints with the old reliable print and place method. Reslice and let's go!